I don't know how long that'll go. We'll just let that go until it runs out. If needed.
Are you going to be able to get home?
If it runs out.
If it runs out?
Yes. What? I walked here. Come on.
Oh, okay.
That's good work. Me too. It's good you didn't
Yeah.
do it,
Right.
'cause
All right. I guess we're going to start. So we're going to be talking about Kotlin. Kotlin is my favorite programming language, actually, but it is imperfect, and I will be quick to criticize it in a lot of cases that we're going to see. So let's just talk about like sort of the background to get the bigger context in case a lot of people don't know it. Kotlin was like birthed from sort of like people in the industry that were basically sick of how verbose and annoying Java was to work with. Java picked up like a huge ecosystem over time and had a lot of like really fantastic tools built on it. And the JVM got really good. So the JVM was like super fast, was being used in like lots of web scale applications. And the problem was that if you wanted to write code on the JVM, you had to use Java, which was not fun. And if you wanted to have more fun and you wanted to write like Scala instead, there were like performance issues, potentially. I'm going to say potentially because there are like Scala people that are like big into performance, but it has performance issues a lot more often than Kotlin does. And also compilation times, which is like another big thing that they're trying to target with Kotlin. So basically they just want to drop in Java replacement. They say we want the JVM, we want the tooling, we just don't want to write Java anymore. Because if you haven't used Java, there's a lot of flaws. For one, it's like super. Okay, a lot of the flaws are gone actually as of like since Java 8. So Java 8 added lambdas, so you could finally have like higher order functions in a lot of cases. Before you'd have to like wrap them in like this callable interface. It was like extra verbose and annoying to deal with. So Java 8 added like streams, it added lambdas, and it was like, wow, I can almost do functional programming, except the streams were super slow. Everything was like, you couldn't do any declarative data manipulation that was eager by default. It was always lazy by default, and it was extremely slow if you were processing like tons of data with the Java 8 streams. Then Java 9 and 10 actually started adding in some like type inference, which is like some of the other pain points that Kotlin tried to address. Because in Java, if you have this like disgusting enterprise code base that has built up like type names that stretch across your monitor, you have to like type the whole type name and then like the variable, and then you have to type the whole type name again when you create it. And over time, as you get longer and longer type names, this actually is enough of a pain that like people want like type inference so that they can just do val whatever the type, and then they'll know that it's correct in the compiler. So anyway, these are a lot of the motivations that JetBrains was pursuing. JetBrains are the creators of IntelliJ, which is like the most popular Java IDE. So they have like tons of tooling. They're like a tooling workhorse, basically. They have like a fantastic interactive debugger. They have like the IDE is great. It's very fast. They took tons of market share away from Eclipse, which at the time was like the dominant IDE. But yeah, so they actually were the ones who decided internally to start building a new language. So props to whoever approved that project, because that sounds crazy to me. So anyway, so there's some interesting things that we'll notice in the language that just come from because it also came from a company that was producing the same tools. So we're going to talk about extension methods later. And in my opinion, like even though extension methods are popular in like some other languages, like the degree to which they're used in Kotlin like really shows that they're just like sort of expecting you to work with like heavy tooling while you're working in the language. And to some people that may be a bad thing, but we'll talk a bit more about that. So other pain points in Java. So in Java, you're basically passing references around everywhere. There's not true value types. And all of these references, unless they're primitives, so unless you're dealing with like ints and longs, they're all nullable. And when I say that they're nullable, they're just implicitly nullable. Anything could be null, and the compiler doesn't know what you've checked. It doesn't know, like, if you just checked that something wasn't null, it doesn't know that it actually could be null or couldn't be null within any given scope. And you can't actually communicate that to callers as well. You can't say, hey, don't pass me something null here. You have to wait till runtime where they still pass it to you as null, and then you just blow up and you like throw an exception. And so you have runtime errors just like fragmented all throughout your application because like the language is just like sort of bad at supporting this idea. So anyway, so they wanted to fix that in Kotlin, so they baked in the optionality into the type system, so they actually have like so the language itself supports like true union types like as sealed classes, but they actually implement their sort of optionals like actually also their true union types, but they're like sort of baked further into the type system, so you just have this question mark behind types to signify that they're sort of an optional type. So this is a string that could be null, and so you can't compile anything where you like just try to do like an operation on that string. You have to check it first, in which case the scope in which you operate on the string will then be non-nullable, or you have to use a safe access pattern, which we'll get at later, which you will know from like C#. If you use like C# has like the safe access pattern, but C# does not have this like baked into the type system. So C# still suffers from like a lot of the same problems in terms of like the dangers of the types, but they do offer like functionality for making it easier to access. Pure data manipulations are better. So in Java, if you're just trying to make an object that like just represents data, it's a huge pain. People like write these manual getters and setters everywhere, and it just turns into like a big mess. And when you're just trying to like manipulate data around, especially if you're trying to make an immutable object, you have to write your own method for like cloning it. It's a nightmare. So anyway, so they did all this, and then to sort of make the marketing easier, they made it interop with Java code super well. So you can basically call like Java libraries as if you were writing them. Yeah.
That question mark notation.
Yes.
You know where that came from?
I don't know. I know Ceylon did it first that I remember, but probably there's another one.
And how old is Caitlin?
How old is Kotlin?
Yeah.
That 6 years now, 7 years maybe. I think it hit 1.0 in, I want to say early 2016 or late 2015. I started using Kotlin right before it hit 1.0, so it was still in like beta land. So I've been using it for several years now. But yeah, I know they didn't invent the question mark syntax. They stole it from other people before them. Swift is like super similar to Kotlin, so you'll see like all kinds of stuff.
I was going to say, I've seen that in Swift, and obviously Swift didn't come up with it. So
right, yeah. So yeah, Swift and Kotlin both stole this from someone else. I don't know who, but yeah, they stole like almost all their good ideas. They stole, which is good if they're not trying to be like an experimental playground for language features because again they're trying to solve a very specific industry problem. So I'm fine with them stealing ideas. So we're gonna run through some quick examples where we're just gonna get like a basic idea of like how the language works, and then from there, instead of going deeper into any specific topics, then we'll sort of like I'll take questions and we can go into any topic people want to know about. So we're making like some kind of student scheduling app. So I just have an enum for days. I have data representing like my lecture and just like what days the lecture happens on. I'm not getting more specific than the day because this is going to blow up in complexity if I do that. And then we have students, and for their schedules we just say like on this day I have these lectures. That's just a multi-map sort of structure. Okay. Any questions about this? Yes.
the enum class, what are enums really? Are they just renaming integers, or are they something else?
Yeah, they're just like a type safe wrapper sort of over integers. I can.
Okay. I mean, they're obviously going to implement it as integers. Ultimately, I'm just wondering if they.
Yeah. So you. So interestingly, you can actually. So by default, if I do nothing else, they'll be integers. But actually, the enumerations are for any like any like sealed set of a heterogeneously shaped class. So in Kotlin, I could make day have a bunch of fields, but then every single enumeration will also have to declare all those fields like right here, and they all have to be shaped the same. If I make them shaped in a different way, then they can't be an enumeration, and they have to be like a sealed class, which is like a different thing. But either way, you get the compiler benefits of the compiler knows all the possible things it could be. So it's similar to like, it's what they call smart casting. It's like similar to the optionality check. So if you check if the day is Monday, and then in your if statement, everywhere in that statement, the compiler will know it as Monday and not as potentially anything.
What about the mutability here?
Mutability?
Yeah, what we see here. What's mutable and what's not?
Nothing is mutable here. So val means the reference that we're talking about is immutable. So for student,
Sure.
the name and age and schedule can't point to different things.
Right.
String is the same as the Java string, which is immutable. Int is immutable because it's like sort of it's a box around a primitive, and all the collection data structures in Kotlin are read-only by default. So both map and list are read-only here, so they're immutable. And you would actually literally have to call it mutable map or mutable list to get an interface that like would let you mutate.
Is there a different keyword? There's no like different keyword like with Scala. You have var for mutability.
Yeah. So right. So there is. So yeah. So any of these vals could be vars if I wanted the references to be mutable. But like, so the difference here, if I made schedule a var instead of a val, then I could assign a whole different map to schedule, but the maps themselves I couldn't change.
Right.
So here with it val and it map, then like both the reference and the collection are both immutable. Yep. Anything else? Cool. All right. Example 1. We got a function. So this is like sort of saying like how we would want to like change a name, and by that I mean we're just doing a transform on a student where this copy notation just means that we want all this data to stay as is, except we're just going to overwrite the specific field that we asked to overwrite. So here we just took in this new name and we're just overwriting just the name field, and we're returning a new student because it's immutable and we can't do that otherwise.
Okay, so it's returning an immutable.
Yep.
It just happens to have one field different from the thing it was copied.
From the input. Yep.
Yep.
So and the input is still unchanged. We just took it, and so this .copy notation is something you get for free on any data class. And so that's like what you use to sort of say like I want to keep everything the same but change this one field.
Yeah, and it would throw an error at compile time if like new name was an int and you try to reassign name to an int.
Yep.
Okay.
Yeah. So this is all strongly typed here. So this is respected, and the typing goes as far as as far as the optionality. So there's no question mark here, so it has to be a name. So if you tried to say name equals null there, that would also not compile.
So this is object oriented, right? You get your classes. What on the left? I'm assuming we're instantiating a student by the parens there. Is that how do you? That's returning a student.
We're on the left.
On the left,
So this is a standalone function. There's no like objects we're doing anything with here. And the lowercase student. So maybe it's hard to see because of the casing here.
No. I mean the uppercase student.
Yes.
Could that be thought of as instantiating a student class?
Yes. Yeah.
Okay.
So .copy is making a new student class.
Okay.
So
and you're wrapping the parens, and that's just saying here's a student, but it's actually derived from this other one.
Yeah.
Okay.
Yeah. Anything else?
And the paren colon student curly, that's just declaring this returns a student.
Correct.
That's not declaration.
Yep.
Okay.
Yep.
Okay.
Yeah. So that just says
Right.
So we have this function. It takes these two inputs. It returns a student, and then here's the body.
Gotcha.
Okay, so how flexible is this changing one field?
Because you change two fields in that statement.
Yes.
Well, not so much that, but the question of what about if like string there? If you had a short string to start in the thing and then you copied it was a long string, does that?
Like different string forms. So Kotlin's using like the Java string, which which is this like complicated thing that under the hood is like trying to do various things to stay optimized. If I was using two different, like let's say I was using an int versus a long, there are certain. So I think you can move up in precision for free, and then you can't move down in precision without an explicit cast. So if I pass.
Okay, but I'm talking about like with your new name there.
Yeah. Mm-hmm.
Can that change the size of the structure? And maybe a better question would be to just generalize it a little.
Yeah. So
can you have fields
mm-hmm.
for val whose type is any type?
Yes.
Okay.
Yeah. So I can be less specific on for types there's like the tree of types at the not close to the top but not quite at the top of the tree you have any which like all the non-nullable types inherit from, and then above that you have any question mark, which is you're saying like anything or not there at all. So you can use those to effectively like erase your types and say whatever. The idiomatic way would probably be to just use generics though. So after change name I'd have like brackets and I'd have like my t like placeholder. So then I would so I'd pass that through, and then I would have to have this be like I almost said template because I'm working in C++ all the time, but I would have to have this like sort of like have a generic specifier and then make that what the name was. And that would and all that would buy me is that would just ensure that when I called that I was using the same type as is declared here. But if I was using any, I wouldn't have that protection. So whenever I would want to turn it back into a string, then I would have to do like a runtime cast, which could
But it does sound like then those could be union types too.
For which piece?
Eval.
I could. I mean, yeah, totally.
Because in some sense, an any is just a universal union type.
Yes. Yeah. If I want to make a union over like a small set of things, there are sealed classes that like let us do that. I don't have any slides that talk about sealed classes, but we can go into them on the REPL afterwards if you want. But right. So yeah, I could say I don't have any good examples like here, but yeah, I could say it's like it's either this or it's this, and they can be heterogeneously shaped.
So I had one question. It kind of carries over with this, but with the classes, you said they're immutable. So what if, like in this case, we started offering Saturday classes? How would you implement that? Would you have to go back to your class enum and modify it directly?
Yeah. So when you say, I mean, yeah. So I don't think anything breaks here if I just add a field to the enum.
But I'm saying, can you do that outside of the scope of where you're instantiating at?
Outside of the scope of where I'm instantiating.
I hope not.
So like the enumeration is like compile time fixed to these kind of fields. So I can't dynamically say later that I'm accepting new versions or not, sort of after it's been compiled. I would have to go for a different strategy altogether. Yeah, I mean, yeah. So enum classes and sealed classes are both cases where it's just like I know all of the things this could be at compile time. Right. And if you want to throw out that guarantee, it's okay. You just have to choose a different strategy because now you have runtime branches to worry about. Whereas if I was using enum classes or sealed classes to handle like branches of logic, I would not have to. The compiler would ensure that I would not have to worry about making like the else branch of like, ooh, what if it's something else I didn't prepare for? And so I don't have to worry about doing that. But if I wanted it to be able to vary dynamically, then I would have to do that.
Are we slowing you down?
No, this is fine.
All right. So far, from what I'm seeing, I see functions and I see classes.
Yep.
Is there a concept of a method? Is it different than a function?
Yeah. So this is like one of the things I don't like about this language, actually. So the creators of the language have to make it like very catering to be able to interop with Java, right. And also just to not scare away Java developers. So because of that, so these functions can be standalone and they can just do operations on data, which is like generally how I like to write things. Yeah. But there are cases where like I could put a curly brace after here, and now I would have a class, and then if I put functions inside there, they would be methods in the class.
So it's almost like that's where your static
It's not quite like static.
Methods, it's actually
it's not quite like static. They are like true methods. It's just that like but yeah, that's how you would add them there.
I see.
And like whether or not it's appropriate for your use case. But yeah. Anything else? All right. Okay. So just some coverage into like sort of like we're getting into like some of the Lambda stuff here. So earlier when I was saying that they implement a lot of the standard library through extension methods, these are what I mean. So students here is just a collection of student. Collection is just like a high level interface. It just means like I can iterate over this and it has a size. That's like all it really means. And I use it when I am being a little bit more precise than a list, because like a list has like indices and has like an ordering, but like a collection does not. So here I'm just taking students, and so dot sorted by and dot for each here are both extension methods that are implemented on collection in the Kotlin standard library. And what this means is that if I make a new thing that is it implements a collection interface, these things that are implemented elsewhere are going to work with my collection, and I don't have to implement like my own specific type because they operate through my external interface. So here I do dot sorted by on the collection, and then these curly braces that we see is the Lambda syntax, and it here is the unnamed Lambda parameter. In Scala it's an underscore. So like here I didn't name the Lambda parameter, and then right here with the S I did name the Lambda parameter. So that's like the difference in like how that looks. Mm-hmm. And so here I'm just sort of saying that like, and sorted by takes a Lambda that just like produces whatever value that you're sort of using like the ordering on it to order the collection. So I'm just sort of saying that, okay, I'm going to sort all the students by their name, and then I'm going to loop over them with the for each, and then I'm going to print out each one. And because this is eager by default, so this means that like I'm not lazily sorting and printing. I could do that by adding like this dot sequence call after students. So I can switch control between lazy and eager, but everything's eager by default otherwise. And in this specific case, and maybe in some other cases, like this will compile down to actually everything being copied over to an intermediate list, iterating through the intermediate list, and then doing things. In some cases, if you're just doing like dot filter, dot for each, or something like that, the compiler is smart enough that it'll actually like make it into like just a for loop with if statements.
Does the lazy versus eager actually change the semantics, or is it just an execution thing?
So it depends. So in this case, no. But in other cases, you can, for example, if you return a sequence of things versus if you're returning like the eager collection of them, you are kind of limiting. You can't iterate through the sequence multiple times. So if I am receiving the sequence, I have to collect them into a container of some kind if I want to iterate over them multiple times. But if I'm just consuming messages as they come in and I'm doing something with them, and I don't care about like storing them in any way afterwards, then it's nice and convenient for me. But if you the laziness is nice if you build like a lot of functions that are all operating on sequences, and then you can do like arbitrarily complicated things lazily, which is cool. It's just that you have to evaluate the performance trade-offs of doing that.
Okay, but it's not. So the compiler isn't deciding between those two.
Correct. Yeah.
In a pure function language, the semantics should be the same.
Yeah.
And then it's up to the compiler to say one or the other. In fact, the user in theory doesn't have to specify which they have.
Yeah, in this, I can't on the spot. I can't think of a case. I can't think of a case where the semantics are going to matter like a lot.
Yeah, but as soon as you have side effects, as soon as you have variables, then you've got that potential.
Yeah. So in this, we've got in this everything's eager by default, and you can switch on and off laziness. Any questions? Okay, so more complicated. So here we have schedule, which is this map. Okay, and we another thing that's like is convenient at times, but overall I think I'm like negative on it in the language is they have like some small amounts of operator overloading, plus, minus, and like brackets, basically. So I'm using the bracket access to look into the map. Now, what I get out of the map is I don't get a list of lectures out of the map. I get a list of lectures ? Because it may have not been in the map. So you can't access a map and get out a non-nullable type. So it's automatically gonna like give me that nullable type. And one thing that's annoying with this is that using this versus using like a custom multi-map structure. If you use a custom multi-map structure and you try to access something that's not in the map, you get back an empty list, right? But in this case, because I'm not using a custom structure, I'm just using the default map for like just these purposes to show you, I could potentially get back null. And I'm fixing that by using this operator, which is the Elvis operator. And
It's
how
the
that
what?
works. The Elvis operator.
Oh yeah, okay, yeah.
It's called because if you turn it sideways, it looks like Elvis's
Yeah,
hair.
like it looks like the
Yeah.
ternary. There's a version of a ternary.
Yeah, sort of. It's like I think of it like an else statement, but for
Yeah.
null. So it's basically you're basically saying like if this is null, execute the thing on the other
Right.
side. And so I'm basically saying that like in those parentheses, I'm like get the list out. If it wasn't there, give me an empty list. So this is just like my like hacky way of making a better multi-map interface for myself. And then I take this lecture that we want to do append, I like stick it on the end of that list, and now I have a new list because I can't mutate the list. And then I'm doing a copy transform on the student, and I'm taking their schedule, and then this 2 infix here is this plus in this 2 is I'm taking the map and I'm adding a new key and value to it, and it's producing a new map.
So I'm assuming that these collection classes are all using persistent data structures underneath, so that
So you can choose implementations of them that do. Currently in the language right now they don't, and they just like they either copy everything or they rely on the compiler to like optimize out like cases where you don't. And they have experimental persistent data structures that you can use, and that I've played around with. And so like in my personal project where I do like large maps that I am doing immutable transforms on them all the time, I use the persistent collections then.
yeah.
And so like all the operations work the same way, and like because the same read-only interface works on them, it's just being way smarter about it. And this is the thing that like I would like the compiler to figure out for me, or even the runtime to figure out for me. It's like based on like what the throughput is going through the map, like swap implementations for me. That'd be cool. Not something it does today, unfortunately. But yeah. Anything else?
What happens if they already exists in the map?
They already exist in the map. We get back the list of lectures for that day. We don't execute the other side of the Elvis, so then I just append lecture to it, which may have already been in there.
I mean at the plus data schedule piece, because like that doesn't seem to me like you're replacing replacing the key in the map.
Yeah, the way that the way that the so dot plus is actually the same as using the plus sign. And the way that additive maps work is that like the keys on the right overwrite the keys on the left. So it's kind of like Clojure if you're like merging maps in Clojure. So this is like I agree that's like potentially like a little confusing. I would maybe wrap this in like some kind of interface that made this make more sense. But I'm just using the default data structures to just show what they do.
Didn't you already add the lecture to that day in previous line? Didn't
Here?
it happen there? Yeah, in that line or the next one plus lecture.
Here, yes. This is I'm getting a new list with the lecture appended.
Which is so day schedule is a list.
Yeah, day schedule is a list. Yep. And then day 2, so day here is the key, and I'm joining it to the to this to make a pair. this is pretty cryptic just because I'm like trying to show off as many language features as I can. Like you could look at 2 lines of code, right? like I'm not like I would not really be writing production code this cryptic, but I'm just trying to show off all these things. So we have this list day schedule. I'm
in the previous line you're accessing schedule and accessing a plus is being executed on schedule.
So I'm accessing the schedule and I'm getting the value out of the map, which is a list of lecture. So this line here, this is.
I'm thinking about the last lines.
Here?
The second to last line, you're accessing schedule, which is a.
Right
With
here.
a dot schedule. Yeah.
Gotcha.
Okay.
Yeah. So this is a map. I'm adding a new key value pair to it. Yeah. Yes. And all this discussion shows that like this is a pretty cryptic line of code. So maybe you wouldn't want to write this. Yeah.
Is there a potential ambiguity syntactic because of the? It looks like you have 2 different uses of dot.
Of dot.
I.e., dot in front of plus, which I assume just says it's equivalent to a.
Where do you see dot in front of plus?
Oh, so here.
Bottom line there.
So I'm just wrapping this to fit the slide. So
Oh,
this is
sorry.
student dot schedule dot.
This is like a pipeline of.
Yeah.
I thought that was a separate line down there, and I'm saying so you're using because you said it was equivalent to plus.
Yeah.
And a lot of languages will say there's an alphabetic form of all the all the operators, but you can put a dot to say that it's really an operator.
Gotcha. Yeah.
Okay,
So
that's not what you're doing here.
that is not what I'm doing here. I'm actually calling an extension function on
Yes.
the map interface, which is schedule. But it got wrapped. So this.
And
is
so you do
actually
have an
happening.
end of line character.
There is an optional end of line character, the semicolon, but you usually don't use it. So here the reason it knows that this is part of schedule is because I have this closing parenthesis here. So this closing parenthesis here, it makes it so that the compiler knows that the only place it could apply this is to the end of schedule. Anything else? Okay. So here's the same implementation as an extension function if I were trying to implement one for whatever reason. So we can go back and forth. So here I took in student as a parameter, and then I did all this stuff, and then I returned student. Okay. Here, I don't take student as a parameter. I'm doing an extension on student, and then I'm still returning student. So here, and the only thing that you'll notice is that's different everywhere is that instead of student.schedule, I'm just accessing schedule. And the reason is that this, in the context of this function, in like that scope of this function is happening on student. So it's like, think of it as like a different parameter. It's just overriding this. It's a little weird to write, and I don't like to overuse these because I think they make like who owns the functionality complicated. Yeah. But in terms of writing things that like operate on the data structures in the standard library, this is like how they got the standard library to be so fun to work with, because you can just do like any like data structures you have. You can do like dot map, dot filter, like you feel super powerful, and that's just because they implemented tons and tons of these extension functions. Yep.
Can you implement extension methods on something that is outside of the code you're writing?
Yes. Yep. But unlike closure protocols, for example, you can't use an extension method to implement an interface. So, and this is the thing I don't like about it. So for example, if there's like an interface for like some kind of like serializable protocol that you're like trying to meet, okay, and you have to implement like the 2JSON version of whatever your type is, and like the verbose Java way of doing it was like you had to like make a new subclass of like their interface for the thing, and then you had to like wrap the type that you wanted to use, and then like pipe through all the operations, and it was a huge pain. You could not achieve the same functionality by just using an extension method, because using the extension method doesn't make it implement the interface. It just lets you have a syntactic sugar when you call it. So it's not truly letting you do that. In Clojure you can do that, and that's a really great feature of Clojure. But anything else? Cool. All right, so now we break out the fold. This is how you know it's functional programming talk. All right. So this is just showing off. Oh yeah, and so like I already talked about all this, but this is basically it's just like map and fold here are extension functions, and then notice because it's like this yellow slanted thing, I'm using the extension method version that we implemented in the previous slide. So this version, I'm using that here to do the transform on the student. Now this one, also very cryptic, also something I would probably not write, and it's probably breaking some brains trying to like understand what this is doing. So we're taking in, so these students signed up for this lecture, all right? We're taking in all the students that signed up, we're mapping them all, so we're taking each student, and then we're taking the days in the lecture, and we're folding them into the student by adding it to each student's schedule. And so at the end of add lecture today, we have a new student, which gets folded into the fold. At the end of the fold, we have the new student, which had all the days folded into it. And then all of those students are going to be composed into the output list, which is the map transform. So with these lines of code, we basically modified the maps in all the students to like contain a new lecture. Yeah.
How does Kotlin handle tail recursion? Well, I would assume in fold map that they just, is it stacks? Is it?
Yeah, because this is eager, so that this will get optimized nicely into like it may even. I have not looked at the bytecode that gets generated for this, but it will probably even for the fold implement like actually just do like a mutable reference and then just reassign the same thing over and over again when it does the copy, and then it relies on the JVM to optimize out the data class copies because JVM is like the JVM, especially like with the new like G1 GCs, like super efficient at like reusing like lots of similar objects. So you basically have like two classes that are like immutable, and you have like all the fields that you've copied over except for like one, and like you hope that the JVM under the hood like figured out that it could just reuse the same thing and change the field. So that's like how you get like decent performance out of a lot of these.
Well, what if you're just doing general recursive functions?
Yeah, I mean you can do recursion. I do not know off the top of my head what their tail recursion strategy is if they're doing like trampolining or I don't know actually.
Okay.
But I've implemented recursive stuff before and it did not explode on me, so take that.
So far, it's working.
Yeah, so far, take that for what you will. Okay, cool. So now we can talk about So now we can talk about some of the stuff I don't like. Some more of the stuff I don't like. Error handling. Because you're calling into like Java methods everywhere, and you have Java methods that are calling you have to deal with exceptions, because like exceptions are just going to exist in like the JVM bytecode. So you have to be able to catch them, you have to be able to throw them, and which is okay if you like exceptions, but like a lot of people want to do stuff with like that, like with result types. And the problem is we could make a real result type using like the union types that are built in the Kotlin, so using sealed classes. But the problem is that like unwrapping them and like checking them is like super verbose, because we don't have macros that do that for us. So like people that have used Rust, you have like the exclamation mark macro that checks your result and unwraps it and like propagates it if there's an error. And we don't have that, which is a huge pain, because because if you don't have that, that means that you're writing like if it wasn't the error, like or if it did return the error, then like throw the error, otherwise then continue on. And I don't want to write that everywhere. So I use a mixed approach. If I'm writing code that like I want the errors to like be able to be handled in various graceful ways, then I use like result types. But otherwise, I just use like exceptions for sort of like exceptional scenarios where I just want to blow everything up. And I try not to catch the exceptions and try to not use them for control flow. But it's not as pretty of a picture of error handling as it is in Rust.
So in that case, I'm comparing it mentally to things that are familiar.
Yeah.
So do you have like in Scala, you would have like a map, and flat map, and there are these, I guess they'd be like extension functions here.
Yeah, there is a flat map.
And in things that implement those things are effectively monads. So you have an operational context that you can use, right? So if you had an exception, well, you still have to. Well, I guess I'm trying to think of the way. Actually, the way it's typically done in Scala is you have a try monad that does.
Okay, I'm not familiar with that.
What it does, it's a way of handling the try, but it enables you to
you get like
a
back
return
an
type.
either, and is it just handling like dealing with an either like return type?
Yeah, it does the catch for you,
Okay.
the try catch thing.
Oh,
but
gotcha,
you what you wind up with is you can have return types instead of exceptions.
Okay, yeah.
So they're very nice for that. So
Yeah. Oh yeah, like a way of transforming it.
Yeah.
And you could easily do that. You could easily do that here if you wanted to, because you would just make a generic thing that operated on a generic collection, and then you would just wrap the call and pass through the lambda of what you wanted to do, and then you would return the result type that you wanted to use. That would work. Checking the result type and stuff would still be a huge pain though afterwards, which is why like a lot of people don't do it.
Yeah.
So I don't know. I hope we have a solution for this.
Maybe this is a basic question. I'm familiar with the exceptions. What's a result type, or is that too much of a basic question?
No.
Because
totally fine.
you said, some people don't like to deal with exceptions. They prefer to use result types. And I don't know what a result type is.
Yeah, sure. So languages that want you to be more conscious of how you handle errors. So the problem with exceptions is that like to the caller they're invisible a lot of the time. So you call into something that's writing IO. Okay. And it's just like a void method. And so you just call it. And you don't know the ways it could fail.
Sure.
Okay. And there are a ton of ways it could fail, and some of them you could handle gracefully, and some of them you couldn't probably. And so there's like a move. There's like how do you communicate that like these graceful failure modes can happen to the caller without skipping code, like without skipping out of your call stack by using an exception.
Okay.
So to make it just like part of the return type that you propagate at.
Right.
That's like what kind of result types are. But that's part of it, because if you just say, oh, I'm returning some error information, deal with it, then you have like the situation that you have in Golang, which I hate, which is where you basically they return a value and an error potentially. And so you have to check if the error is there, and you have to remember to check it, because you can forget. And then you have to remember to check it, and then you have to like return the error, and then you can shadow the values. So if you like if you like move some lines around and you forget to check it in between, you'll overwrite the error, and it's like horrible.
Yeah.
So other languages implemented this using union types, where like they return the type and it says like it's either this value or it's this error, and you can't do anything useful with it until you check it.
Right.
And that's like the great way to do it in the compiler, because then it guarantees that I'm not going to just assume it worked, and it also guarantees that I'm not going to like assume it failed or anything like that. I have to check and then do one thing or the other, and the compiler enforces that. So it enforces a lot of safety, and it enforces me to consciously handle the errors. Win-win. Except you have to be careful how you implement it, because if you implement it poorly, then you just have a ton of if statements all over your code, and it's just like annoying to write. It's basically it. And so Rust did this great thing. So actually, it didn't start out like this in Rust. So they have like a great hygienic macro system. So they have these macros that understand the AST, and they can do like really cool things with it. And so people were doing this pattern where they were getting a result, and then they were like checking if like the result was there, and then they were returning it. And so they made this macro that like kind of did that for them, and then that eventually made its way into like the language. It's called like the exclamation mark, which is the best. Like in my opinion, that's like the best way to do error handling. But because it just shortens that, like check if it's an error. If it's an error, return it, and then afterwards the compiler knows that it has the real value. So it's like you have the conscious part of it, you have the shorthand, it's not skipping your code like randomly like exceptions are. So that's how I wish that worked in Kotlin. But
Well, how do you feel about the way the monadic way of doing it? Like if it was Haskell, you'd have a do, or if it was Scala, you'd have a for. You've essentially said, this is the end of the world, here are my effects are happening here. And it is imperative right now. boom, 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 boom. And so they add sugar that makes it pretty brief. I mean, it's not really.
So yeah, I mean, the truth is that I'm just not that familiar with the Haskell approach, or and I'm only slightly familiar with the approach in Scala. So maybe it is great and it would fix all my problems. I don't know. I just haven't used it enough. So. So yeah, and then this thing at the bottom is like a common thing where it's like you use the Elvis combined with your throw or your return for errors. So here it's like I was expecting this value to be in the map. This value had better be in this map. And then you can use that Elvis to just drop through to like throw something, and then this type is a non-nullable type because the compiler knows, and how this works in the type system is that a return statement or a throw statement has a type of nothing, and the nothing combines really well when you're doing like various like union operations. So the compiler knows that if I have a nullable and I have an Elvis and I have a nothing on the other side, then that collapses down into a non-nullable. And so you can do so this is a great shorthand way to like get rid of those like nullables that you know won't be there.
So you've exchanged it for a typed result.
Yes. Yeah. Basically, well, it's already typed. It's just that before it was a nullable type, and you want to narrow that further. Yeah. So some of the direction that they're taking it is that now you can target the LLVM backend with it, so you can do native Kotlin. I have written here that native doesn't mean fast. It's like native Kotlin's really slow, guys. It's like way slower than the JVM, and that like surprises a lot of people. But it's hard to get high level languages working well in native code. Swift is also really slow. People didn't know this. Like Swift is like 8 times slower than C. Like Kotlin native is like 30 times slower than C. Kotlin on the JVM is only like 2.5 times slower than C. It's really fast. So like just use the JVM version. But anyway, so people are pursuing this approach for sort of like the iOS.
Do you know if anybody has done anything with the Graal? I don't know if I'm saying that right. Graal, Graal.
Yeah. It's like the new native like target for like the JVM. So they could write the JVM bytecode and then have that compiled into something native. Yeah. And I have no idea what they're doing with that. Yeah. And I imagine that this will become 2 different flavors of native, which is you'd use the Graal if you wanted to like call like Java libraries because they don't have a good way to import it into native code. But then you'd use the Kotlin native if you wanted to like call into like C bindings and like other stuff in the LLVM backend. So yeah, that may turn into a messy picture where you have these 2 different flavors of native. I don't know where that'll go.
And what about what's that new thing they're doing with WASM? What's that new layer?
The WebAssembly?
Yeah, but there's a new layer that it's essentially that, right? It's a layer that you can write to, that you can target that represents like the system.
Oh yeah. I'm not as familiar with the web stuff. Kotlin can compile to JavaScript. I have no idea how good it is. It proceed at your own risk. I don't know. But yeah. So I'm curious if we'll see like a CLR version Monday, like Clojure did. That'd be cool. But yeah, it's sort of interesting. And then I wanted to rant like a little bit at the end here for basically not really rant. It's just this is like an interesting thing where like you have like a lot of stuff that's built with these extension functions. And it's not just the extension functions, but it's like a lot of like the heavy type inference. Like you'll see, like when we looked at the slide earlier, you'll see that stuff, and you'll scratch your head and you'll be like, this looks super cryptic. Like, what happened here? And this is like sort of getting into this like growing dichotomy where if you think of a language as just the text, like you're looking at it on a slide, it's like way harder to comprehend than if you're like in the IDE and it's like telling you what type everything is, and you're like, and you have like the interactive debugger. And so where some languages like Kotlin and Swift and a lot of these like heavy type inferred languages are entering into this realm where they're sort of like merging with their tooling. And it's like the language isn't just the text anymore. It's actually like the language and the tooling. And that whole ecosystem is what people think of when they think of the language. If I was like using Vim and I was trying to write Kotlin, I think it'd be painful because like, you know, you don't have like a lot of the white space is like weird in the rules you can do in certain situations. And like,
might you change your style if you found yourself writing in?
I probably would, yeah. And I think and discovering stuff that like figuring out how to like manipulate collections. Like a lot of the times, if I'm thinking about it now, it's like I have the data structure and I just like type dot, and I see like all the extension functions for like, you know, it's like, oh, I can do a fold here, right?
But you can do that in a REPL, right?
Yeah. You can do that with like trial and error kind of in the REPL. It's like
you check the completion in the REPL.
Yeah, you can get I'm just sort of saying that like this like how we're designing. We're not only
I'm right on board.
Yeah, we're like approaching problems differently because of the tooling, but then we're also designing the languages differently because of the tooling, and so like I don't know where this is going to go.
Yeah, because if I'm not mistaken, the examples that you're putting out, I don't have as much experience, but wouldn't you say C# and Visual Studio kind of have that same bond?
Yes, especially like the newer stuff they've been doing to C# now, because because C# has extension functions now. They have type inference. They have like a lot of these other things that. But yeah, I agree that like it's this.
That's funny. I was just ranting about this very thing today.
Oh yeah.
To me, it's like if you like IDEs, then you should use IDEs. I mean, there's nothing wrong with that. But if you are juggling so many eggs that you need an IDE, then that to me is a smell.
Yeah, and it's like I don't know. I don't know. I'm not saying here like whether or not I think this is a good thing or a bad thing.
Yeah,
this is like an observation that this is happening, and it's very weird. And we're seeing this with like language server protocol now, is that like it's not like that one producer of the IDE is like, oh, we have the best IDE so we can control everything. It's like, well, really it's like you're making everyone dependent on this powerful tooling, but that powerful tooling is becoming more and more generalizable because of stuff like language server protocol. So it's not really like I don't view it like a power grab by like JetBrains or like by Microsoft in Visual Studio's case, but yeah.
So extension functions, they remind me of traits in Rust a lot, but they lead me to the question of there is the concept of classes and methods. What's the difference between a method and an extension function?
So a method is actually a member of that class, and travels with it wherever the class goes. An extension function you have to import separately and may live and can live in a different package, and also is not reflective of like if you were to by default you can't like subclass things, but you can like open them to subclassing because of the Java compatibility requirements. So the methods are visible to all those layers of the language. If you open it up for subclassing, or if you make it an interface, like the methods are are a piece of that you're operating on. The extension functions really are just they're just free functions that have syntactic sugar, pretty much. They're not like my understand. I'm not super good at Rust, but my understanding of Rust traits is that they're similar to closure protocols in that you can implement a trait on something, and then you can call functions that take in that trait with the thing, and you can't do that in this case because they're just free functions. The way you do it in Kotlin is you take in you invert the control by just taking in a lambda that does the thing, and then you just wrap whatever you were trying to do in a lambda and you throw it in there because the lambda syntax is lightweight. So you don't have the same. You don't have the same power, and that's a thing I hope they change in the language. But
right, yeah, and I wasn't supposing that everything in traits was in extension functions. Just at its simplest, extension functions and traits in many ways are just I've got some data, and I want to sort of and Go kind of has this too. I want to say data dot do this thing with this data.
Yeah.
And I don't even know the words that Go uses for it, but Go has it.
Yeah, I'm familiar. Yeah, I'm familiar that they have it. I also am not sure what to call it. But yeah.
Am I correct, and I'm probably not, that methods are visible everywhere?
They can be
Methods,
private.
methods that we're using like extensions and that, but extensions are really unique to a particular subscope.
Yeah, you have to import them to use them, and if you're in a package that like doesn't have those same extension functions, then you can't use them. So like you may have written, whoops, this is the end apparently. But you may have you may have like written a great extension function for string that like converts that internationalizes it for you somehow, yeah.
Sorry.
And which is great and all, but then if you're accessing that from a different package, because you're still using string, you're not using some new type you made. You'd also have to import that extension to use it. You don't just get it for free, and that's like the difference between like actually extending string or like writing a new thing. But yeah.
So this was clearly oriented towards FP features and so on.
Yeah.
So I'm assuming there are things that you didn't talk about a lot.
Yeah, like for example, like methods and classes.
Yeah,
like,
or just object-oriented ways of doing things in general.
Yes.
So
yeah.
How does inheritance and those sorts of things, is it encouraged that you do that, or is it?
No, it's generally discouraged. So they actually so in Java you can make a class final, which means you can't inherit it.
Right.
And that's like the default for everything in
Gotcha.
Kotlin. So you actually have to use a keyword that like lets you inherit it, because they want you to not do it.
Right.
Because they want you to not do it, but they know they still have to support that
Sure,
code compatibility. So you have to like use this open keyword. So you have to open a class up to let someone else subclass it, and by default you can't. And so that's how they try to. So they do things like that, and also like how like it's a list interface means read only, and then like mutable list means like, so they're trying to push people in that direction, but it's a very, very gentle nudge because they know that they have to support all like the JVM bytecode.
So why is subclassing considered to be non-functional?
Well, because it implies that you're adding. Because it implies, so like the reason you would subclass something is to add a behavior to an object.
Never mind.
And the idea of the objects having behaviors is like an OO thing, and versus them just functions operating on them. Yeah.
I'm used to languages where that is not a problem.
Well,
which would be great if that it'd be great if that's the world we were in Java.
Yes, right,
but unfortunately, no.
All right, and so I would guess suffice to say it's probably no multiple inheritance. That's why.
You're correct.
So I would say that these extension classes correspond, like you said, to traits or mix-ins of some kind, and that's another way of extending what you have.
Yeah, kind of, but they're just very weak. They're just syntactic, sure. There's nothing special you can do with them.
You mentioned overloading and the fact that was discouraged or not promised or something.
In my head, I don't like them, but it's not officially. People like to do it.
Well, the reason I was asking was because you had plus used as a list concatenation operator there, it looked like.
Yes, I did.
And I assume it's also an arithmetic operator, so that looks like overloading to me.
Yep. You are correct. Yeah, right here, and here. This slide wrapped hardly. This I don't think this would be a valid line break. I'm pretty sure I would get an exception, or a compiler error here. But anyway, but yeah, I mean, right. I agree that that's overloading, and I don't like that. Again, I was just trying to like add as many features in here as possible. So this plus for the map, I could actually just put a plus there, and that would actually like work also.
Just something to think about. If in fact it's never ambiguous because of types.
If it was never ambiguous, then like I agree, it wouldn't be.
I think the problem with overloading arises because in lots of traditional languages anyway, subclasses, subtypes.
Yeah, you don't know what it's doing.
Are not in fact full-fledged types.
Oh,
Okay.
Right? They're just extra conditions that you test for.
yeah.
And so you can't tell from what's required by virtue of the syntax there.
Yeah, you have no idea what it's doing. It's like, it could be, it's like you can do a plus sign. It could be like calling your database, right? It's like, oh, I don't want that to happen. Yeah, so. All right, cool. Well,
Nice.
thank you.
Thank you.
Can we get copies of your slides?
Yes, I will send out.